We are going to continue section 6.1 by using the greatest common factor in factoring. And that's really the very first step whenever you approach any type of factoring problem. You think, is there a number or a variable that goes into every single term? So if we look at number 6 right here, 49x and 35, is there a GCF? Well, the GCF happens to be 7 because 7 can go into both of the terms. What happens is you pull out the GCF from the two terms, and then whatever's remaining goes back underneath the variable, back to the so 7x minus 5. And then you just kind of make sure with 7x minus 5 that you take the greatest common factor, which we did. And in later sections, you'll see if you can factor that. But for right now, that's all we can do. So this is how we factor with the GCF. You'll notice that if you were to multiply or distribute this 7 to each of the terms, you would end up with the same result we started with, or the question, 49x minus 35. Looking at number 7, we have two terms. We have z cubed minus z squared. And again, you have to think about what GCF is. Well, the GCF for this case is going to be z squared, meaning z squared can be taken out of both of them. So I'm going to divide each term by z squared, and that goes on the outside. And what's remaining is z cubed divided by z squared, that's z. And then z squared minus z squared is minus 1. So that would be our final answer. Go ahead and pause the video and do problems number 8 and 9, pulling out the GCF from each term. In problem number 8, you'll notice I took a negative 2b. B is the highest variable with the highest exponent, and the coefficient, the highest common factor, would be 2. Now I took out a negative just because with formatting, usually you want to make that leading coefficient inside the parentheses positive. So that's why I divided by negative, so that it would become positive 6 right there. In number 9, you can see that I took out 9xy cubed. Again, x to the first is the highest exponent, y cubed is the highest exponent. I took it out from each one, so that would be your final answer right there. We're going to continue with factoring, but we're going to kind of look at it from a different factoring question. And this kind of gets into the factoring by grouping process. You'll notice that we have x and 13 multiplying this quantity y minus 1. And notice in the parentheses that they are exactly the same, y minus 1. We have x multiplying the exact same binomial as we do with negative 13. Well, think about what that is. Taking the x and we are distributing it each one. And then we're taking the negative 13 and we're distributing it each one. And that just kind of seems familiar. This is kind of like the FOIL process, we talked about in chapter 5, except for the x and negative 13 are separated. So what happens is, to factor this, I'm going to regroup x minus 13 in one parentheses. And then this y minus 1 right here becomes its own grouping as well. And so I factor this by rearranging it into two binomials. And again, based on the foiling process, you can see that this is really the same. If I were to FOIL this, I take x and I distribute it by y minus 1, just like I did here. And then you're going to take negative 13 and distribute it here. Again, the same process there. This happens only when the parentheses are the same. So again, you'll notice in number 11, the 2m plus 2m plus n are exactly the same. So that becomes one grouping in itself, 2m plus n. But then you'll notice probably that we have this 5x squared and this y cubed. Then there's really nothing out there. Now, think back to what that means. If there's no number in front of a variable, in front of parentheses, it implies that there's 1. So again, I'm going to take those and regroup them together to get 5x squared y cubed minus 1. And then that's going to times quantity 2n plus n. Continuing with our factoring by grouping, one way that you can factor if you have 4 terms is through this process called factoring by grouping. So if I have 4 terms, what I'm going to do is I'm going to kind of make a split down the middle, and then I have 2 groupings. 2 terms on the left, 2 terms on the right. And what I'm going to do is I'm going to look at each pairing individually. Is there GCF of those 2 I can take? Yeah, which is an A. So I take out an A and I'm left with B plus 4. And I'm going to look at the second grouping and ask myself the same thing. Is there a number that I can take out of both terms or a variable? There is. A positive 7. And what's left is a B plus 4. Now, this will seem very familiar compared to the last 2 questions. Parentheses match up. So you're going to regroup those to be B plus 4. And then I put A plus 7 together to make another group. And if you were to do the foiling process, guess what would happen? You'd be right back to the beginning. I'm going to do the same thing with number 13. I'm going to split it down the middle. I'm going to look at what is grouped together, or what GCF I can take out of those 2, which is a 7x squared. And so I'm left with 4x minus 1. And then here, I can take out a 3. So I'm going to take out a positive 3. And I'm left with 4x minus 1. And I'm going to read that. 4x minus 1 gets grouped together. And the 7x squared plus 3 gets grouped together. All right, go ahead and try 14 and 15. Pause the video, and then I'll put the answers on when you resume. And these are the results for 14 and 15. You'll notice in number 15, there's something I want to point out. 3x plus 4y, there's no GCF. So what you do is you actually pull out positive 1. So if there is no number, you take out 1, so that that is part of that binomial.